And this video is going to focus on how our streams flow and the different factors that cause it to change over time. When water is flowing through a stream, it can move in two different ways. The first is called laminar flow, and this only happens when the water is extremely slow moving. And in this case, the water is going to move in roughly parallel layers within the stream, and it's going to make it look like the water isn't even moving at all, which is what we see in the foreground of this image on the left. But the other type of stream flow is called turbulent. This is where the water is moving a little bit faster, and it's going to move erratically because it's moving so fast. It's going to start swirling around, and as it moves, it's going to start moving some of the sediment from the bottom of the stream and picking it up within the water itself. So we see that as our water increases its velocity, the rate that it's moving, it will increase the turbidity. If we think about the fastest streams in the world, which are our whitewater rapids, they have incredibly turbid waters. There are multiple factors that can affect the flow velocity, or how fast the water is flowing through an area. And we're going to see that a lot of it depends on where we are on the stream, whether we're in that mountainous headwaters or that coastal mouth region. But the main things that are going to affect our flow velocity, the main thing is going to be the gradient, or the slope of the channel. Where we have steeper slopes, the water is going to move faster. Anytime we have very gentle slopes, the water will move much slower. But it also depends on the size and the depth of our channels. Generally, we see when they get wider and deeper, the water slows down. But the channel roughness will also be important, and this will come up again in a couple of slides. And the channel roughness is the size of the sediments making up the stream bottom. If it's a lot of really coarse or big sediments, the friction's going to slow the water down. But if it's very fine, smooth sediments, the water will be able to quickly just glide across it, allowing it to flow faster. So again, the gradient is just the slope. It's a change in the vertical distance over a specified horizontal distance. But the steeper that the gradient is, the faster the water will flow through the area, and the more energy that water will have as it's flowing down that steeper slope. And again, we see that the channel roughness will also be important. If we have larger, coarser sediments, it creates a lot of friction, and it's going to slow down that water. But if we have very fine-grained, smooth sediments, there will be less friction, and the water will have a higher flow velocity through that area. If we could cut a river in half and look at the way that it changes from the mountainous headwaters to the coastal mouth, we'll see that almost every single river has the same shape to it. And we call this shape the longitudinal profile. Overall, it's a concave shape. It kind of dips down towards the center, kind of like a contact lens. But we're going to see that overall there are some different properties that either increase or decrease as we're moving downstream from the headwaters to the mouth. We'll see that the gradient will decrease because we're going from really steep mountainous areas to a flat coast. And as the gradient decreases, we also see that sediment size decreases as well. In our mountainous areas, we might have boulders, but by the time we get to the beachy areas along the coast, it's mostly smaller sand-sized particles. This also affects the channel roughness. With smaller sediments, it'll be smoother sediments, allowing the water to move more quickly. But on the other hand, we're going to see that the discharge, the total amount of water, will increase because we have multiple rivers joining together as it's moving towards the mouth. And we're going to see that the channel size increases as well because as it's holding more water, it will have to increase in size.